Circles are among the most primitive of basic shapes. For a long time, they have been used in everything from domes to ancient and modern architecture, giant clocks such as this one, and art like with this meticulously made stained glass window. The Earth itself, with its almost spherical shape, all of which have elements of a circle. In order to use a circle, it is often required to know its basic measurements. We will call the distance across this not-to-scale circle 4 feet. This is known as the diameter. Now comes the tricky part. How do we measure the distance around it, otherwise known as the circumference? What's more, circles are not always small. In this case, measuring around this circle, which is 400 or 4,000 feet or more, would be tedious, time-consuming, and definitely not accurate. This was the case that puzzled so many mathematicians, so many people trying to construct, until somebody found a better way. Who was genius enough to discover how to measure circumference? Recorded history makes it a little hard to tell, but we've narrowed it down to the Egyptians and the Babylonians. Now let's look at what exactly this ancient discovery was that changed mathematics and the world as we know it. First, in review, the circumference is the distance around the circle, the diameter is the distance across. The comparison between the two, namely circumference divided by diameter, is the key. Let's take a look at why. Let's take a look at 3 circles with varying sizes, thus different diameters, namely 5, 25, and 50. With a lot of difficulty, we could at least approximate the circumference, or distance around the circle, as close as possible. Using the comparison, dividing circumference by diameter, we see that this comparison is the same no matter what the circle's size. Hence pi. The comparison was born. Pi is constant. It's a real number. It is also, as we call it, irrational, because it goes on and can't be made into a fraction. We can now multiply any diameter by pi, and we have any circumference. Let's look at an application now of pi. The Earth is close enough to being a sphere, a fraction of a percent off, that we can rather confidently approximate the diameter, or distance through its core, a daunting task otherwise, in comparison to circumference. That we can do using pi. Neither is easy to measure, but the circumference is measurable, while the diameter is only found using our new discovery. Let's look at some choices as you might see them on a test. Which of these is your guess? Now with a simple calculation we can conclude the problem and solve for the diameter of the Earth. Earlier we found that pi times diameter is equal to circumference. And substituting in the circumference of the Earth, we now need to get rid of the pi or isolate the variable. And one of the ways we can do that is dividing both sides by pi. Pi divided by pi is equal to 1, therefore we're left with just the diameter, and diameter of the Earth is equal to 24,880 divided by pi, which is 7,920. Thus, eliminating the false answers, we find the right answer to be the diameter of the Earth is 7,920 miles.